So hello guys, welcome to this is a part 2 about all this Spark information. So section 10 project scenario. So first question they will ask, tell me about yourself. So answer is like, hi, good afternoon. My name is Maurice Patil. I am a data engineer with 3 years of experience building scalable pipeline and lakehouse architecture across the cloud ecosystem. Currently, I am working at Cognizant, where I have contributed to two major projects, enterprise project. First, pharma data migration into Apache Iceberg on AWS S3. I built the ingestion pipeline from source like Oracle, CSV, XML, and REST API, and optimized Spark job and to improve query speed by 40% and reduce pipeline execution time by 30%. The second project was ECDP for 16 plus terabytes of financial data on Azure. I built modeling architecture on AWS Gen 2, developed ADF pipelines, wrote write PySpark transformation notebooks, and set up a CI/CD pipeline for automated deployment. My technical expertise includes PySpark, SQL, Python, Databricks, ADF, and AWS Gen 2, and I am certified in Databricks and Azure fundamentals. Beyond the technical side, I follow the modeling architecture principle to ensure strong data lineage and compliance. In short, I bring the mix of hands-on engineering, performance optimization, and cloud expertise, and I am passionate about designing reliable and efficient data solutions that directly support business outcomes. Second question is, biggest technical challenge. The 20 terabytes of migration was biggest. The legacy system was alive. Zero downtime was hard requirement. The technical challenges like our initial partition design uses a patient ID as a patient partition column, creating 10 million tiny direct territories on S3. Metadata listing was taking longer than actual data processing. Designed the partition strategy, switched to year of event date as a partition column and used the iceberg Z order on partition ID and facility ID for data skipping within partition. This reduces the file count by 89 95% and cut scan time efficiently. When we then run the migration in parallel with validation gate at each layer before cutting over. Next question is, how do you achieve 30% reduction in pipeline execution time? It was combination of targeting optimization, not the one single fix. First, I replaced short merge join with broadcast join for all small reference tables like XRF piping, facility code, drug lookups under all under 20 MB. This estimate multiple shuffle stage. Eliminate multiple shuffle stage. Second, I tune spark.sql.shuffle.partition from default 200 to number appropriate for each job data volume. Some job only have 15 distinct keys. 185 empty partitions were wasted tasks. Third, I fixed the partition design on iceberg table so DPP means dynamic partition pruning trigger correctly. Queries that were scanning the full 20 terabytes of data now scanning only 11 data range. Fourth, I enable AQE and auto coalesce remaining empty partition and handle the ready residential queue. Together, those dropped end-to-end data pipeline from 4 hours to under 3 hours, 30% reduction. 15 plus hour week automation, PySpark SQL generation. We had 30 plus 300 plus SQL script that create a script view and procedure that need to be maintained by dev SQL and production environment. Manually updating schema names and configuration for every environment was taking a lot of time and consuming error. So I built a Python automation framework where the table detail were stored in configuration file and Python dynamically generate the required SQL script for each environment. Example, dev schema, production schema. The script automatically replace environment space value and execute the SQL. This reduces manual effort by more than 15% per 15 hours per week. Standardized deployment and eliminate many manual configuration errors. Question number 40 74. A pipeline arrival 3 hours late. How do you go down us? My approach is like first step, check the EDA pointer. Did the trigger fire on time and or was there in a delay in the source file arrive? Step 2, check the Databricks job log. Which stage took longer? Third step, open Spark UI for slow stage. Look at event time for struggler task. Data queue. Check step shuffle read or write size. Too much shuffle. So and check input size full scan instead of partition tune scan. Step 4, run explain in bracket formatted. Is DPP active? The is there any unnecessary short merge join? Checking. Root cause, I have seen data skew on the one key. Fix broadcast or salt. A DPP not triggered. Fix align the filter column with partition column. Un upstream source delayed. Fix event based trigger instead of schedule. Question number 45. Where did you see data engineering in 3, 4, 5 years? I see big data. I see big shift happening. First is open table format war is sitting. Iceberg and Delta table are winning. Every major cloud provider is converting those format. Deep expertise in them is becoming table stake. Second, streaming is become the default, not an advanced feature. A real-time pipeline on the lakehouse table will be standard, not special. Third, AI argument data engineering tool that auto-generate pipeline, suggest optimization, detect anomalies. Data engineer who understand the fundamental deeply will use those tools efficiently. 40, 50, 76 section. Production pipeline failure debugging under pressure. Tell me the scenario of this. I had a critical pipeline failure at 6 a.m. 2 hours before the business needed to daily report. Step 1, check the EDA for error message. It should JDBC connection timeout to Oracle. Second step, configured Oracle was up. Time issue was our JDBC connection will use being exhausted by parallel job we have not had not coordinated. Step 3, fix added connection properties to limit max JDBC connection and rerun the pipeline with failed pipe partition only. In bracket, not a full load. Step 4, added Oracle connection monitoring to our alerting dashboard. So this is the master quick reference. Strong line. Spark means driver plan, executor execute, and CM allocate means cluster manager allocates resources. Shuffle, disk on write plus network plus serialization, performance killer. EQE, static planner, dynamic optimizer at runtime. Broadcast, zero shuffle on large side, zero shuffle on large side, immute data skew. UDF, black box to catalyst, always prefer add native functions. Iceberg, acidic plus time travel on open S3 storage. Hidden part, partition logic in metadata not query, auto tuning. Delta, parquet plus delta log is equal to acidic plus time travel. Medallion, raw in, quality out, each layer adds trust. Meridian, in raw MDM, one trusted record from many sources system. Independency, merge not insert, save to run after failure. Unity catalog, one governance layer for all database workspace. Key vault, zero secret in code, non-negotiable security requirement. CI/CD, automated set on PR, automated deploy on merge. Kafka, distributed log offset model enables exactly once. Let's write and how we can write and read the different source system. First, Oracle df is equal to spark dot read dot format jdbc dot option driver comma oracle dot jdbc dot driver dot object oracle dot jdbc comma dot option in bracket url comma oracle url, then option user comma username, option password comma password, option fetch size comma 500, option query comma select star from table name dot load bracket complete. And while writing df dot write dot format jdbc option url comma jdbc url, option user comma url username, option password comma password, option table tdb table comma schema dot output table name dot mode append save bracket complete. So then csv, so we have to give the manual schema. Structure schema is struct is equal to struct type bracket square bracket struct field bracket id comma integer type comma true bracket complete comma struct field comma name comma string type comma true bracket complete, then square bracket complete square bracket complete. File csv underscore df is equal to spark dot read dot format in bracket csv dot option save acp comma colon option header comma true, option quote comma slash dot accept comma slash dot load in bracket path. Spark cannot directly control file name, so we rename using S3 API or Hadoop FS. So for XML read, so df is equal to spark dot read dot format in bracket XML dot option raw tag comma transaction dot schema in bracket schema name schema we defined, then dot load in bracket path. Then smartsheet we have url and token name. Token is permanent, so import request url is equal to the url given by the source. We have to just give the sheet id need, then header is equal to we have to create dictionary, in dictionary authentication colon bearer the token bearer and special token. So response is equal to request dot get in bracket url comma header is equal to headers is equal to header, then data is equal to response dot json in bracket complete, then df is equal to spark dot create data frame in bracket data square bracket rows. Then smartsheet we are like what we are doing, wait a second. Okay, smartsheet we are like for smartsheet Salesforce API we build a pipeline that ingests Salesforce data using REST API. First we authenticated with auth2 to get an access control, then we run the OSQL query and handle the pagination with next record URL. Then we use fetch all record across the multiple pages. We added retry logic with exponential backoffs to handle rate limit and server error. Once the data is collected, we convert it into data frame and add audit columns. Let's go one by one. First here we imported import request, then import time, then we have to import the Spark functions, then we are return the retry logic. In that like logic function we write the retry function name is make underscore request. So in that we are taking the URL header params and maximum retry logic is 3, backoff factor is equal to 2. So in that we are like what we are doing, attempt is equal to 0 while attempt is less than max retry ID, means 0 is greater than 3. If it is true, then we will in try we are using like response. So first we will go first here. Okay, here like authenticated to Salesforce. So we have authenticated URL given by the source. Then we have payload. In payload we have dictionary, grant type, client secret, client ID, username, password in payload. Then we are giving the post request like authentication auth underscore response is equal to request dot post in bracket authenticate auth URL comma data is equal to payload comma timeout 30. So auth underscore data is equal to auth underscore response dot json bracket complete auth underscore data in bracket access token. We have to give access token to access token variable. Then we are taking instance URL from auth underscore data. Then step 2, prepare header. Header is equal to a dictionary authentication token bearer access token comma second key is contact dash type value is application slash json. Step 3 is create a SOQL query. SOQL query is equal to select star from table name, then query URL, like we have to create query URL using instance URL slash service slash data slash v59.0 slash query. Then param is equal to param is the dictionary, in that q is a key and value is SOQL underscore query, means select star from table name. So we are reading all pages, like we are creating empty list called all underscore record. So now after that we are calling that function we created, that make underscore request. In that we are passing query URL, header and param. So in that function it will use the get method, like response is equal to request dot get in bracket URL header is equal to headers, param is equal to params, timeout is 30. So we are getting, if we are getting status code is equal to 200, then we are returning the response, JSON response. So once we get the response, once if it is fail, it will go to the else block attempt plus is equal to attempt plus 1, then wait time will sleep, time will sleep and it will retry again. After getting the records from that make underscore request method, we are storing into the JSON into response, and we are creating all underscore record, it is empty list, all underscore record dot extend in bracket response dot get in bracket record comma empty list. So extend is all each element of list individually into all run, and in response we will get the next response URL, and in that we are creating again like next URL is equal to instance URL plus response in bracket square bracket next URL, and that next URL we are giving to the next, like make, we are again creating the getting the response is equal to make underscore request in bracket next URL comma header is equal to headers, and it is in while loop. Let's dive into the REST API. What is REST API? REST API is a web service that allows HTTP standard view installed with API with method like post, get, delete. Each endpoint return the structured data in JSON. In PySpark, the driver driver call the API using Python requests library, not on the worker, because REST API call need coordination, state and token management. How we are taking the token, like import request header is equal to, how we are getting the response, import request header is equal to dictionary authenticator colon bearer token, then contain dash type value like application comma JSON. You will get the JSON response, like so response is equal to request dot get URL, means like the URL we are giving in header, and also we can give param select from query, like that. Get is used to fetch or read data, and post is used to fetch protocol division record. Next, how do you handle authentication with REST API? First, I use authenticator password grant. First, using post method get the credential, we are fetching token. The token that take the token and start into table, fetching all records using get method. I attach every request to the authentication via token. How do you handle token expiry? On 401 response pipeline failed, not failed. Enter retry loop, sleep for 30 seconds, call get underscore token method and compare the previous one. What is pagination and how do you implement it? Pagination is technique that split large dataset into smaller chunks. Instead of returning all records in the single response, each page having fixed records, ideal 15, and much loop and I like through loop pages until we have fetched everything. What is an API rate limit and how do you handle it? Rate limiting is when API restricted how many resource request you can make it in time window. For example, 100 requests per minute. Exceeding it returns 429. Too many request error. Handling, like first we add API rate delays like 32 to 5 seconds using time dot sleep in bracket 300. 300 is millisecond. 300 millisecond means 5 seconds between the each study API call. Using incremental load whenever possible. The reduce the number of API calls and it helps within the allotted time.